So if we know that the OLS model is going to be fundamentally flawed when we have a binary outcome, we might ask a natural question, right? What is a better way to model this? Well, I think a first natural way to think about this is we can start kind of breaking down our patients into bins, and we can think of them in a frequency table of age groups, right? So in the far left, we have age groups, so people 20 to 29, we have about 10 patients that would fall into that category. And all we're going to do is we're going to look at the percentage or the proportion of those participants that have CHD. So, for example, if we look at that age group, 20 to 29, of the 10 patients, we see that only one, or about 10%, of that age population has CHD. So we're going to do that for all of the different age groups. Now, when we look at that in a plot, we can see, so again, for that age group from 20 to 29, we have a very low proportion of respondents or patients that have CHD. Now, as we see, as individuals get older, the mean or the average CHD for those individuals goes up. So when we look at people in the 60 to 69 category, about 80% of those individuals display a presence of CHD. Now, this is really nice because essentially what this is allowing us to do is the estimated values in the table are pretty close to the expected value of y given x. So we are assuming that this is actually providing a pretty useful functional form to model the relationship between age and CHD. So let's go back to this graph for a second, right? So we would anticipate that you as an individual in a higher age range, 60 to 69, let's say, would have a higher probability of having CHD. So we might say they have an 80% probability, right? That looks very similar to 80% of the individuals in that age group have CHD. And so we're going to leverage this relationship. This is nice because the conditional mean, right, has to be greater or equal to 0, and it's got to be less than or equal to 1. So this is necessarily going to bound our predicted values between 0 and 1, which is nice because our outcome is between 0 and 1. This is something that we would not have gotten if we used OLS. Again, what's also nice about this is that the plot is showing the gradual mean, how it approaches 0 and 1 gradually, right, as we run along our continuous variable of age. So what happens because of that necessarily is that the change in the expected value of y, so the change in your propensity to have CHD given your age, that becomes progressively smaller, right, as you approach 0 and as you approach 1, right? And that makes sense, right? If we look back at the previous graph, as you get progressively younger, right, your propensity to have CHD would decrease and become smaller. But the same could be said if we go to the upper end of age, right? We could see that your increase between going from 50 in that later 50 age group to 60, the decrease between those two is actually quite small. The highest increase in risk appears in the middle of that distribution. So what can be said about this is that the curve represents an S shape, and this is very nice because this looks very similar to the cumulative distribution functions of a lot of continuous random variables. And so we're going to use that fact and incorporate some very well-known CDFs to model this expected value of y conditioned on x, right, when y is dichotomous. And the function that we're going to concentrate on today and for the next couple of modules is the logistic function. Now, here is the logistic function. Get very familiar with it because you're going to see it continuously for, like I said, a number of modules moving forward. But if we graph the logistic function, we can see that it looks very similar to that S-shaped curve that we pointed out in the graph earlier. So for the rest of the lecture, we're going to be talking about the intuition behind connecting the logistic function to what we've been using before, a linear model, right, of a change in X in a change in Y. And so now we'll just be talking about how a change in X, so how a change in age affects the propensity of an individual to experience CHD.